All right, good morning, everybody. Today I want to cover topics 9.5 and 9.6, which is on global warming. Just kind of getting into this a little bit today. I mean, again, this is one of these big topics, which global warming impacts the entire planet. It's not just like one specific location, even though some locations on the planet might be affected more by global warming than others. Again, this is global change, which is the title of this unit. But again, this particular topic does cover pretty much everybody. I mean, we all need to be concerned about this topic. So we're going to start today talking about polar bears. Polar bears, I think, are kind of a microcosm of what's been going on with the entire planet when it comes to global warming. So just a little bit about polar bears. I think we kind of know that they are sort of at the top of the food chain, in the Arctic ecosystems. They're kind of these tertiary predators. They typically feed off of seals, and they depend on their sea ice, to to kind of set up their, I guess, predatory region, where they're going to prey on these seals that pop up through these holes in the ice. Seals have to come up to breathe, so the polar bears kind of know where those seals are, and they've had this, predatory relationship with seals for thousands and thousands of years. Not only that, but the polar bears are also important to other organisms in the ecosystem. For example, this is the Arctic fox, which is a scavenger. After the polar bear is kind of done, kind of picking through the carcass of the seal, the Arctic fox kind of comes along, kind of picks off any scraps that might be there. So, the Arctic fox kind of depends on the polar bear to make the kill, and then he kind of comes along later on and just kind of scavenges the rest of the food. So that's kind of an important relationship that the Arctic fox has with the polar bear. Now, obviously, you've probably heard this before, but the area where these polar bears live, up in the Arctic, their Arctic ice has been melting. And this picture here kind of shows you sort of what's been happening, at least the trend. 45% of the Arctic ice is gone, compared to what it was, just 30 or 40 years ago. And if that's happening, then obviously polar bears are struggling. The ice, normally does thicken in the wintertime and it thins in the summer, but the thinning has become much greater, due to global warming. This polar bear, let's say, for example, this is the middle of the summertime in the Arctic. It's not supposed to look like this. Now, in the wintertime, it will freeze over, which is good. But again, in the summer, it's becoming too warm. So again, these polar bears are having trouble finding their ice holes to find seals, and again, they're struggling to find food. One of the big problems with a lot of these polar bears, because they're struggling to find food, they're losing a lot of weight. They're having difficulty just surviving. Their population numbers have declined 10% just in the last decade alone, and they're predicting it might go down to 40% in the next 20 to 25 years. So this is a species that's really on the decline, and they're really in trouble. And that's global warming is not the only reason why. I mean, some things we've talked about before, for example, biomagnification. Polar bears are at the top of the food chain, so any chemicals that might get in their environment are going to move up that food chain and build up in the bodies of the polar bears, so that can be an issue. Hunting and poaching has always been an issue with polar bears, even though we do have laws in place to kind of protect them now. And finally, oil spills. We've talked about Exxon Valdez, for example. Anytime oil gets in the water, that can be problematic for polar bears. So again, I mean, this is a species that is really threatened to go extinct. All because of some anthropogenic things that humans are doing. But global warming, might just be kind of the tipping point that really pushes this particular species to the brink of extinction. All right, so polar bears, I think, are a good introduction, to global warming and climate change. Global warming, it says here, is the warming of the oceans, land masses, and atmosphere of the Earth due to increases in greenhouse gas concentrations in the atmosphere. Global warming, again, is an entirely anthropogenic thing. Those greenhouse gases are getting into the air and they are causing the planet to warm. And this can cause something called climate change. Climate change, it says here, is the changes in the average weather that occurs in an area over a period of years or decades. It results in increased storm intensity, altered patterns of precipitation and temperature, and altered patterns of ocean circulation. So again, climate change. Remember, climate is basically just um, the weather patterns in an area over long periods of time. What we're starting to see is that these weather patterns are starting to change drastically because of global warming. So that means that for example, like take a biome like the tundra. The tundra is used to having specific weather conditions over long periods of time, and that is now changing. So that means that the tundra is starting to change. It is happening with every single biome. So global warming can impact kind of the parameters of biomes. All right, now the evidence for global warming, some of this stuff we've talked about before, so I'm going to kind of skim through it. But there's a group of scientists known as the IPCC. And the IPCC is the International Panel on Climate Change that were formed back in 1988. This is a group of scientists who strictly study global warming. And specifically, what they're looking at is the link between greenhouse gases or greenhouse gas emissions and global warming. We talked about this, last week. The biggest greenhouse gas that we have to be concerned with is carbon dioxide. And we can see just the overall trend in carbon dioxide buildup in the atmosphere. Currently we're at about 415 parts per million. That is the highest that we have ever been. This graph only goes back to 1954, but we'll look at one later on that goes back millions of years, and you'll notice that this current amount of CO2 in our atmosphere, again, is the highest it has ever been in recorded history. Now, again, we've talked about this as well. I mean, carbon dioxide is not the only gas, the only greenhouse gas that we've seen increases in. You can pretty much pick any greenhouse gas, whether it be carbon dioxide, nitrous oxide, methane, CFCs, or HCFCs. I mean, they're all on the increase. CFCs have again been kind of curbed a little bit because of the Montreal Protocol, but everything else is just again continuing to rise, which is definitely an issue. This graph here is showing us, how those greenhouse gas emissions have impacted temperature. What we're looking at here, on the y-axis, it says temperature anomaly. What this basically is if you look at the 0 mark, that 0 represents the average temperature during basically 120 years of records. So this goes from 1900 to 2020-ish. So that 0 line is kind of the average temperature. It's not 0 degrees, but anything above this 0 or below this 0 represents the difference compared to the average. So, for example, like back in the 1900s, these blue lines here, mean that we were a little bit below the average temperature for that period of time. But anywhere you see an orange bar, that means that year was above the average temperature. Now, yeah, there were some, above average temperatures in some of these years over here. But what I want us to kind of focus on is more recently, especially in the last 40 years. I mean, pretty much every single year, I mean, give or take one or two, pretty much every single year has an average temperature well above normal. All right. And this is a trend that we just haven't really seen. And it's attributed again to greenhouse gas emissions. Certain areas of the world are kind of experiencing this a little bit more than others. You notice here in this picture, the darker orange colors represent again just differences from the average temperature. These regions up in north, like the tundra of Russia, the ice caps up in the Arctic. I mean, these are areas that have experienced much more drastic temperature changes than other places around the world. Typically, we're seeing a lot of this change in the northern hemisphere. So again, all that Arctic sea ice where the polar bears live, that are getting the brunt of a lot of this temperature change due to greenhouse gas emissions. Now, one of the reasons that we know a lot about greenhouse gas emissions and how they're building up in the atmosphere compared to what they have been in years past is we look at ice cores. Ice cores, we typically can drill down into the ice in the Arctic, and when we drill down and remove these cores, we can look at a couple of different things. One of the things that we look at are the bubbles that are in the ice core. We can look at carbon dioxide, for example. Let's say, for example, this little piece of ice from ice core, let's say they date it back to, I don't know, 100,000 years ago or something. They can actually measure the amount of carbon dioxide gas that's in that particular ice so that they can get an indication of what the atmosphere was like, 100,000, 200,000 years ago. Another thing they can look at is oxygen. There's actually different isotopes of oxygen. There's oxygen 16 and oxygen 18. Oxygen 16 is more common in warmer climates, and oxygen 18 is a little bit more common in colder climates. So what they can do is they can look at the ratio of those two isotopes in the ice core, and they can actually get a really good indication of what the temperature was like just by looking at the ratio of those oxygen isotopes. So there's a lot of science that actually goes into um, ice core research and figuring out what climates were like, but they actually do have ways to figure that out. One of the big things that we found from the research that the scientists have done with ice cores is they've been able to kind of look and see, what carbon dioxide levels have been like going back 400, 500,000 years ago. And again, you can kind of see this that, there has been a trend for carbon dioxide levels to drop and to rise and drop and to rise. And that's been kind of normal, throughout history. But if you look at where we are right now, again, I go back to, right now we're at about 415 parts per million. This is unprecedented. There's never been a time in history that we've ever been that high. In fact, the previous high was about 130,000 years ago. We were at about 200 and maybe 90 parts per million. If you just look in recent years, this spike here, this is completely due to anthropogenic reasons. So this number is way too high. All right, I'm going to stop the video here for today, or at least for right now. And I'm going to give you guys a little bit of a break and have you come back and watch the second half of this video. All right, guys, have a good day. I will see you soon.